In this video we're going to talk about integration by parts. We're going to go through the proof of the formula and some classic parts examples. So let's see. So basically integration by parts is the integration equivalent to the product rule for differentiation. It's basically finding the integral of the product of two functions. An example of this can be x times e to the x, and anything along that nature. So in general it is f of x. I'm gonna drop the of x. All these functions are functions of x, so I'm just gonna write fg prime equals f prime g plus or fg quantity prime equals f prime g plus fg prime, and that's the product rule for differentiation. So basically we want to find the integral of the ultimate goal is to find the integral of two functions being multiplied together. So we take the integral of both sides, and let me just do that on this line. Dx dx, and obviously we can, well, from here, let's see. Well, the left side, this side, is just the integral of the derivative, so that this cancels out. That's just fg. The right side, let me just rewrite it. F prime g, we can split up into two integrals like that. And from here we can move this guy over to the left hand side. Let me just copy him, and I'm just gonna move this to the right, to the left, because that's how it's normally written. I like that. So it's fg prime dx equals fg minus the integral of f prime g dx. This I'm gonna do a little bit of substitutions here to put it in a more standard form. We're gonna make u equal f of x, and therefore du is equal to f prime of x dx. And another substitution, we're going to do v equals g of x, and dv equals g prime of x dx. Okay, so let's plug these relationships into this expression. So this f turns into a u. Then we have g prime dx, which is dv. So what did I do? Okay. Yeah. G prime dx, I think it should say. Yeah. That's what I should have said, rather. So the left side turns into u, the integral of u dv. And the right side, we replace f with u, g with v, and then we have f prime dx, which is du, and then g is v, so this is v du. And this is the standard form of integration by parts. Now, but what does this mean? It's kind of hard to see what it means right off the bat, and I'm just going to do some very extremely classic examples of integration by parts. If you're doing parts, you're going to do all three of these examples. It's pretty much a given. Because they should just show up all the time. So the first one it will just be, let me just, example 1. Let's see, it will just be the integral of x times e to the x dx. And actually, I think I'm going to switch it up a little bit and make this a 4. Doesn't matter. It could be x, it could be 16, doesn't just number. So, basically what you do is you have to sort of relate this to the u dv form on this left. And this is what it boils down to. You pick a u, this is what you pick. You pick a u and you pick a dv. That's what you pick. And when the u you differentiate and the dv you integrate. So, and it's your choice. We can pick u is equal to x or u is equal to e to the 4x. Doesn't matter. But typically, the way it's typically done is you set u equal to the function that quote unquote gets less when you differentiate it. So if you set u equal to x, then du is equal to dx, and that's just because du dx is equal to 1, and then you quote unquote multiply both sides by dx, and you get that. So we picked our u, and therefore we have a du. Now you don't pick a v, you pick a dv. That's important here. You pick dv because if we're comparing this integral to the left side and our u is x, then everything else is dv. So e to the 4x dx is our dv. So let's see, dv equals e to the 4x dx. And now we need to get a v. So we integrate both sides of this, and what's the integral of e to the 4x? Well, that's 1/4 e to the 4x. This, you can forget about the plus c's. They don't matter in this case. And alright, so now we have that. We basically just go over this again. You pick a u, you differentiate, and you get a du. Then you pick a dv and you integrate and get a v. So now we just follow this formula: u times v minus the integral of v du. So u times v is 1/4 x e to the 4x minus the integral of v, which is 1/4 e to the 4x du, which is dx. Now we can evaluate this again because now we have a simple integral to do.